Alright, this is my video summary for Fabric of the Cosmos, Quantum Leap. So this one was interesting because I've heard the term quantum leap before. Didn't know what it was in reference to, so it was cool to learn about. They start off by talking about quantum mechanics and how they kind of govern all of our electronics and how really just kind of how everything runs because of how reliant we are on electronics. So they talk about the quantum realm. And so with the quantum realm, they talk about how electrons aren't just here or there, right? Or they are here or there. There's a lot of different disagreements about different studies and how they study the quantum realm, but what it basically boils down to is that electrons don't like to stay in one place, and they don't take one path. They take several paths. So they could be here or they could be over here, right? It could be there or here. But they're not going from here and traveling across to here. It's instantaneous. It's from here to here. One of the main guys that talked about the quantum realm and things like that, his ideas came from electrons, and it was Bohr. And so he believed that electrons were in fixed orbits. And what led him to kind of deem this term quantum leap was they heated up tubes full of different gases and then put a prism next to it, and the light would shine through. And what was happening was it was causing these strips, right? So it was causing strips like this of different colors of light, which is unique because usually when light shines through a prism it causes a spectrum. So it would be something like that as opposed to distinct lines. And so what he theorized was that electrons are constantly jumping from one shell to another shell. And the energy always has to be exact. So when it jumps a shell or jumps an orbit, it emits a light, right? It emits light in the form of just a line instead of a spectrum, right? Because there's different leaps happening all at once, but that's where the term quantum leap comes from. It's from an electron jumping from orbit to orbit. One of the main experiments that they talked about was the double slit experiment. And what they did, they were testing to see how electrons work. And so they took this sheet and had two slits in it, and then they bombarded it with electrons. And what they were expecting was that this, and it was just going to be these two, right? That's what they were expecting, because they were expecting that electrons, because it's a particle, it would shoot through, hit there, and it would just be in those areas. But what they found was it was all over the place, but they ended up in these columns. And the reason for that is because there were two kind of theories with it. So Schrodinger said that electrons became smeared, so they weren't just a particle, so it would just kind of go, and then when it went through, so they'd get hit here or they would go through. If they went through, then they would smear out and they'd kind of hit all over. Born talked about how there's a probability wave and how matter it's not certain, it's based on probabilities, right? It's just so these areas, it's more statistically likely that if you look there, you'll find an electron. So it was kind of an interesting little thought process. Still trying to wrap my head around it a little bit. But basically, the two ideas broke down to this. Bohr said that it wasn't there until you observed it or till you measured it. Einstein said that it's always there. And this kind of sparked some debate, specifically about quantum entanglement. Because what quantum entanglement is, it's where electrons share properties. And so Bohr said that when you measure one electron that's entangled, the other one changes, right? So they're alternating back and forth. They're going, and then when you measure it, you've got the one, and then the other one's going to change because you measured it at that moment. Einstein said no, it's always the same whether you measure it or not. It's a certain principle. And so that's where this idea with the box with gloves in it came from. They talked about how if you sent one box to the North Pole and one to the South Pole, you opened it, one would have a right-handed glove, one would have the left. The gloves were always there. It wasn't until you opened it that you knew which glove was there, though, right? But the glove didn't change, is what Einstein said. Clauser actually went out to prove that Einstein was correct, but he ended up proving that quantum mechanics was actually correct, and that measuring the effects, or measuring an electron, affects the outcome of the other. It was a cool little experiment that he did with it, but I don't have time to kind of go into it. And then they kind of concluded with teleportation. So in the Canary Islands, they're currently sending messages via photons through entangled particles. And what that does is it causes, they encode it with information, and then because they do that, they can send it to the entangled particle that's some distance away. But what ends up happening is it destroys the original. So teleportation on a large scale, if you were to copy the information on your DNA, it would destroy who you are, but it would project you onto other particles. So just kind of, it was an interesting thing. And then they finished with the quantum bit, or the qubit, and how that's increasing processing power and the ability to kind of move information through. Because what it does, it's not binary, so it's not a 1 or a 0, and it doesn't just navigate one path, it investigates all the paths at once. And then they left it with the little caveat of, because of all this and all the different quantum things that we don't understand, there are multiple different outcomes, but all outcomes are happening all at once, just in different universes. So that kind of sets up their next little documentary, but pretty cool one. Quantum Leap. Very interesting. I didn't realize it played that big of a role in our lives. But there you go.